Hello, today we'll be teaching you about particle motion.
These are the questions you need to know by the end of this lesson. What is position, velocity, and acceleration? How do I find the position, velocity, and acceleration of a particle if given a time-based equation? And how does physics relate to calculus through particle motion?
The vocabulary for particle motion. Position is a particle's location after a certain time. Velocity is the speed of an object in motion in respect to time. And acceleration is an increase in rate of something. Prerequisite skills. So you see this man walking left to right. This means his position is changing. He starts from an initial position -10 and ends at 0. Since his position changed, that means there is a velocity. Also, he accelerated when he started walking and when he stopped walking.
Practice problems. So these are the following questions you should know how to answer if you're given the time-based equations. Where does the particle start? When does the particle stop? Where does the particle stop? When is the particle moving to the right or left? And when is the particle speeding up or slowing down?
Pause this video to try this by yourself. If you don't know it, then wait to the next slide.
Here is a sample problem. So the first question is, where does the particle start? Since no time has passed, time equals 0. So you plug in 0 as t. The answer is -1.
Pause this video to try this by yourself. If you don't know it, then wait to the next slide. Next question is, when does the particle stop? When the particle stops, the velocity equals 0 because the position is not changing. So you make the equation of velocity equals 0. After you factor this, you should get x equals -1/2 and x equals 5/3. Since time cannot be negative, the particle stops at 1.667 seconds. Pause this video to try this by yourself. If you don't know it, then wait to the next slide. The next question is, where does the particle stop? Since we already found that the particle stops at 1.667 seconds, you plug it into the position equation to find out where the particle stops. After you solve this, the answer is 11.037.
The next question is, when is the particle moving to the right or left? For this problem, you need a horizontal line graph. The particle will move right or left when the particle stops. Put the time of when the particle stops on your line graph. Then you plug in a number below and above 1.667 into the velocity equation. We chose the numbers 1 and 12. So the answers are -6 and 775. Since v of 1 is negative, it is moving left. Since 775 is positive, that is when it's moving right. This is the answer.
Next question is, when is the particle speeding up or slowing down? When the particle stops accelerating, make the acceleration equation equal 0. Then put the answer on the horizontal line graph. Then pick numbers on each side of point 3. We picked point 0, 1, and 1. Plug in point 0, 1, and 1 into the acceleration problem. The answer on the left of point 3 is negative, and the answer on the right is positive. Now find your right or left velocity line graph from the question before to compare the two graphs.
To figure out if the particle is speeding up or slowing down, you have to know these facts. If the signs on the velocity line graph and acceleration line graph are opposite, the particle is slowing down. If the signs are the same, the particle is speeding up. Back to the problem. Divide the line into the time periods. In the first part, since the signs are the same, it is speeding up. In the middle part, since the signs are opposite, it is slowing down. On the right side, since the signs are the same, it is speeding up. This is the answer.
Create created using Powtoon.